Yes, welcome to Easy Gates K22 Easy Solutions. We'll get into the next problem. Yes, this one from digital electronics, but having the analog components. Okay, operational amplifier. So this is exactly a digital to analog converter. R to R ladder DAC. Okay, so that's a circuit given. Probably a 2 marks numerical answer type problem. Okay, so what's given? Okay. So what is the problem? Assuming ideal op amp, the output voltage V0 in volts straight away. Okay, so problem is for V0. So what is the best way to approach the problem? It's worth of 2 marks. So we have two excitations. This is 1.6. This is 1.6. The best way to approach the problem is because we don't know how he has played. Okay, you have the fundamentals of DAC. Okay, digital to analog converter. We know. Okay, so and we don't know who is the MSB, who is the LSB. Okay, so we played with, we practiced, but we don't know who is the MSB bit line, who is the LSB bit line. So better play safe. Just go by principle of superposition. Apply superposition. Take this as a signal V in 1 and take this as a signal V in 2. Activate them one by one. So then you will get V0 as V0 1 plus V0 2. So V0 1 due to V in 1 alone and V0 2 due to V in 2 alone. That's a plan. So go by superposition. So let us switch off V in 2, enable only V in 1, get the response V0 1. And then switch off V in 1, enable only V in 2, get the response V0 2. Probably when you play for V in 1, you may get a good idea for V in 2. That means probably it won't take same time for V in 2 like how much time you have spent for V in 1. Because V in 1 is going to give you knowledge of the circuit and then you're going to speed up analysis of V in 2. You can complete the problem probably within 4 to 5 minutes. Okay, during the examination also. Yes. Now let me go with the superposition. So first I'm going for calculation of V01. I'm going to enable only this V in 1. So V in 1 is set to 1.6. I'm going to switch off this. Switch off this means connected to ground. Then the problem is very easy. And op amp is in linear mode of operation. So it is going to maintain virtual short between the non-inverting and inverting. Therefore, this is going to be due to the virtual short. This is going to be at virtual ground. Okay, virtual ground. Shortly I'm writing should V ground, VGND. Okay, it's closer to 0. Okay, then how to play quickly? Yes, if that is the case, this 2R and 2R will be in parallel. So effectively, the resistance you're going to see from here is going to be R. 2R to R parallel will be R. Then what is the resistance you're going to see from here? It will be 2R because this R will get added with R. Then this is 2R means then this 2R and this 2R will be in parallel. Again, what resistance you're going to see is R, and what resistance you're going to see from here is going to be 2R, and that 2R will be in parallel with this 2R. Again, the effective resistance is going to be R. That means the effective resistance seen from here is 2R, and effective resistance seen from here is 2R. That means the circuit is going to resemble something like this. That is 1.6 volt. This is 2R, and this will be 2R. And this will be 2R. Okay, that's a play. A quick play. R2R always will help you. Okay, quickly play. It may look complex when you begin, but it's simple only. Okay, then what is going to happen? This 2R and 2R will be in parallel, and that is going to be in series with this 2R. Then find out this current. So what is the current actually drawn from this 1.6 volt supply? Yes, what is that current? The current is going to be 1.6 volt divided by the total resistance seen by this. What is the total resistance seen by this? This 2R, and this 2R, 2R parallel will be R. The net resistance will be 3R. Therefore, the current will be 1.6 by 3R. Let me come back to the circuit with this current. So the current is going to be 1.6 by 3R. Okay, take it with a proper unit in amps. Okay, 1.6 volt divided by 3R. R is probably given in the problem as 1 kilo ohm, and but need not to use that value. Without that also we can complete the problem. Okay, I didn't remember exactly. The moment it is given, I went straight away with R, 2R and the given 3R in the feedback. With that, we can go for V01. So let us calculate V01. The focus is on getting V01 now. Yes, then how we are going to play quickly means, yes, this is the current coming in, and you know this 2R these two resistors are, okay, I'm using 2R. These two resistors are 2R and 2R. That means the current will be equally divided. Therefore, this current will be half of this current. So it's going to be 1.6. Otherwise, let me take this current as I. So this current is going to become I by 2. Again, it is 2R. Again, the current will be divided. This current will become I by 4. Again, there will be a division. This current will become I by 8. And again, there will be a division. This current is going to become I by 16. Okay, that's all. Okay. Yes, then no current into the inverting terminal of op amp. The same current will be going through this. The current going through this is going to be I by 16. That is going to make a drop of I by 16 into 3R. So I by 16 into 3R will be the voltage across this 3R. Then from this 0 volt, you're going to lose this. Therefore, V01 is going to become minus of I by 16 into 3R you will get. That's your V01 quickly. So V01. You may feel this is relatively lengthy, but any other route also will consume same time. Okay, this is better and smarter route. Okay, so V01 is going to become, substitute I, it is going to be minus 1.6 volt divided by 3R, the whole divided by what? 16. That's I by 16. Okay, I by 16 into 3R. Yes, what do you get then? Then 3R will get cancelled. You will end up with minus 1.6 by 16. So it's minus 1 by 10. The result is going to be minus 0.1 volt. Okay, yes. So that's a response when you activate only V in 1, where V in 2 is made 0. Okay, remember we are going by superposition. So same circuit, you would have a copy of the same. Yes, it takes time in the exam. So we're going for V02 now. Okay, so this is disabled. Okay, this is 0. And this is very easy. Why? Because this 2R will be in parallel, effectively R. And here you're going to see R plus R, it is going to be 2R. Then 2R will be in parallel. And here it is going to be R. Again, here it is going to be 2R. And this 2R will be in parallel. And effectively, this is R. And then this R in series with this R, you will see again 2R. That means this 2R and 2R again will be in parallel. Remember, it's an actual ground this side, virtual ground this side, still you can play. So therefore, okay, where I am now. Okay, with respect to what I have to see, that's very important. Yes, so this is where I have to see. So therefore, yes, small change in the perception. I thought 1.6 is here, okay, but actually it is here. Okay, now what is this? 2R will be in parallel. It is going to be R. Then this is going to be 2R. Yes. So this 2R parallel effectively going to make the net resistance seen here is equal to 3R. So then again the current I. Okay, we'll go for this current. What is the current here? It is again going to be 1.6 volt divided by 3R. That's a current. Okay. That's a current I. And you know very well this is going to get divided now. That's relatively easy comparing to the last one because you already got the habit. That habit will help you. This is I by 2 and this is I by 2. Again, this is going to be I by 4. This is going to be I by 4. And go for the interested current, and op amp inverting terminal current is 0. Both the currents are in fact 0. And op amp still maintains that VD equal to 0. That's why you're playing like this quickly, okay, with the R2 or ladder network. So the current is going to be I by 4. And don't forget that this point is at 0 volt. Okay. And here you're going to get a drop of I by 4 into 3R. That's a drop which you're going to lose from 0. So that's your V02. You're going to get V02 as minus I by 4. You're losing I by 4 into 3R from 0. Okay. Go by simple point potential. It's very easy. I by 4 into 3R you will get. Therefore, V02 will be equal to, substitute your I. It's minus, so I is 1.6 volt by 3R and hold by 4 into 3R. Again, 3R will get cancelled. The result is going to be V02 equal to minus 1.6 volt by 4. Okay, probably R is given as 1 kilo ohm. You can play with that current also as a number. Okay, so but still you will end up with the same response. Instead of R's, you can play by actual numbers. So then V02 is equal to minus 1.6 by 4 is going to be minus 0.4 volts. Therefore, what is the answer? You got V01 minus 0.1, V02 also follows similar steps of your V01, but this is rapid because it is excited here. Then you can have a small check. Probably who is your MSB now? You guess who is your MSB. That's extra level of understanding. So probably this is LSB and this is your MSB. Okay, so this is probably your B3 bit, this is B2 bit, and this is B1 bit, and this is B0 bit of your DAC, a small verification only. So B2 bit makes what? Minus 0.4. If B2 bit makes minus 0.4, B1 bit should make what? Half of it. What is that? Minus 0.2. If B1 makes minus 0.2, B0 should make what? Minus 0.1. Yes, that means you're confirming that you didn't commit much mistake. Okay, no mistake. Okay, you can take that way. So this B0 already contributed. This B0 line made 1 is contributed minus 0.1. If suppose if all are connected to 1.6, you can imagine now this is minus 0.1, this is minus 0.2, this is minus 0.4, this is probably minus 0.8. It will be the output. Okay, that's a maximum output this 4-bit DAC can produce. Okay, yes, that's answer. Finally, V0 is equal to V01 plus V02. That is equal to minus 0.1 volt plus minus 0.4 volt. So the answer is perfect answer. V0 equal to minus 0.5 volts. I guess it is up to 2 decimal places. Therefore, your answer must be minus 0.50 should be your answer. Yes. Yes, you have to feed with minus. Okay. Yes. So that's a very interesting problem. Okay. In digital electronics based on digital to analog converter using R2R ladder DAC. Yes, we'll update you with one more problem, and do subscribe our channel and also share to your friends.